Assalamualaikum and have a nice day everyone. We are from Group 7. This is Presentation Hydrology Project BFC32002 Class Section 2. Before we start, let us introduce our lecturer for this class, Dr. Hatini binti Kasmin. These are the members of our group consisting of 2 men and 3 women. Hi, Assalamualaikum. My name is Muhammad Zarif Danish bin Zamri. My matrix number DF220007. For this project, we were instructed to find rainfall and water level data to study the floods that occur in Malaysia. We have discussed in the group to choose a state of Perak as the research case for flood difficulties in Malaysia. The 3 stations that we choose are located in Kampung Gajah as Station 1, Station 2 Teluk Sena, and Station 3 Pasang Api.
Hi, my name is Muhammad Aiman bin Abdul Latif. My number matrix is CF230074. Now, I will continue part of methodology. In this project, the application that we use is Google Earth Pro. So, in this application, we need to plot the station and outlet that we choose. This application also can find the station area. Next, the website that we use is Department of Irrigation and Drainage, which is DID webpage. In this website, we need to choose the water level and rainfall station in one state. So the state our group choose is in Perak. In this project, we use 3 methods, which is arithmetic mean method, Tissot polygon method, and isolated method.
Now, this is the part of the data presentation that we have researched on the Banjir Public Info website. In this slide, it is show a rainfall data. We have taken the data of the 3 months highest in 1 year and the 5 days highest for each of 2-3 months. The 3 months highest for Kampung Gajah Station are November 2022, March 2023 and June 2023. For Teluk Sena, November 2022, July 2023 and August 2023. Finally, Pasang Api Station, November 2022, December 2022 and May 2023. For water level data, we take the data according to the same date as the rainfall data provided. So this is the data we got after researching on the website Banjir Public Info.
Next is analysis and result. First method to measure rainfall data is arithmetic mean method. In November 2022, average of Kampung Gajah is 12, average of Teluk Sena is 7.6 and Pasang Api is 6.7. So, total mean area rainfall is 8.77 mm on November 2022. In May 2023, average of Kampung Gajah is 23.3, average of Teluk Sena is 7.4 and Pasang Api is 20.2. Total mean area rainfall is 16.79 mm on May 2023. In August 2023, average of Kampung Gajah is 5.9, average of Teluk Sena is 2.7 and Pasang Api is 15.7. So, total mean area rainfall is 8.1 mm on August 2023. Next, other method that we use is Tissot polygon method. In November 2022, the precipitation that we get is 9.86 mm. In May 2023, the precipitation that we get is 20.52 mm. Lastly, in August 2023, the precipitation that we get is 8.55 mm. The method that we use is associate method. Total precipitation is 360,000 divided by 3,990 and get is 77.71 mm for precipitation in associate method.
Next is cross-section for upstream in Teluk Sena. For the first picture is cross-section and elevation profile, and second picture is how to get perimeter and area. We insert into table for the calculation. We got the slope from the elevation profile and we use n is 0.03, hydraulic radius from area and perimeter, and then we got the flow using formula. The answer is 23,260.71 meter per second. Next is cross-section middle stream in Teluk Sena. For the first picture is cross-section and elevation profile, and then second picture is perimeter and area. We insert into table for the calculation, and then we got this loop from elevation profile, and we use N 0.03, hydraulic radius from area and perimeter. Then we get the flow from formula. We get the answer is 14,352.07 meter per second. For cross-section in downstream in Teluk Sena, we get the perimeter and area from the picture and slope for elevation profile, and we use N 0.030 and hydraulic radius from area divided by perimeter, and we get the flow using formula is 4,333.01 meter per second. Next is rational method. Rational method for Kampung Gajah. We got the constant from MSMA. To calculate average rainfall intensity using formula, we got the answer is 147.25 mm per hour. And then we calculate the peak flow from the average rainfall intensity using formula. We got the answer 445.65 meter cubic per second. Next, for Teluk Sena, we calculate average rainfall intensity. We got the answer is 152.32 mm per hour, and our peak flow is 1608.94 meter cubic per second. For the Pasang Api, average rainfall intensity from formula is 179.02 mm per hour, and our peak flow is 479.77 mm cubic per second.
Hydrograph, a diagram of a river, stream, or other water system discharge over time is called a hydrograph. It usually shows an increase or decrease in water flow versus time, which can be hourly, daily, monthly, yearly, depending on the data recorded. To plot a hydrograph, we have to calculate the area, parameter, hydraulic radius, velocity, discharge by using the formula of A, area equals to By, parameter P equals to B plus 2Y, radius R equals to A over P, Q equals to 1 over N AR to the power of 2 over 3 S to the power of 1 over 2, V equals to 1 over N R to the power of 2 over 3 S to the power of 1 over 2, and Q equals to AV. So this is how the hydrograph for the Teluk Sena on 22nd July 2023 looks like. Same goes to the hydrograph for the Teluk Sena on 30th July 2023. Here is the data and how the graph look like. This is the hydrograph for the Teluk Sena on 5th of August 2023. Straight line method. The approach using the straight line technique shown here offers a straightforward approximation for separating the base flow from the rapid response flow. The resultant line is the dividing line of the base current. It divides the region of the hydrograph generated by short-term rapid response flow from the entire section produced by long-term baseline flow. So this is how the straight line method for Teluk Sena on 22nd July 2023 should be. To plot the unit hydrograph, we should first calculate the base flow, direct flow, and UH ordinate by using the formula of direct flow equals to discharge minus base flow. UH ordinate equals to direct flow divided by runoff there. So this is the unit hydrograph for Teluk Sena on 22nd July 2023. Same goes to the unit hydrograph for Teluk Sena on 30th July 2023. Here's the data and how the unit hydrograph looks like. And this is the unit hydrograph for Teluk Sena on 5th August 2023.
The discussion of our group is the measure of error rainfall has a distinct value. We obtain three different values from the computation because of three methods, which is arithmetic, TSM polygon, and associate method. The outcome of every data set is influenced by various factors. The simplest way to determine the average rainfall over a basin is to use arithmetic. The result is calculated by dividing the total amount of rain that has been measured at various rain gauge stations located across the basin by the total number of stations. Each rain gauge station rainfall data should be weighed according to the region itself. Second, when the final station is located in a challenging terrain and there are relatively few rainfall stations compared to the basin area, the most precise method is to use associate, which are contours that connect location with equal rainfall. By interpolating between gauge data and taking topography into account, Associate are drawn over the watershed at predefined interval.
For the conclusion, in this study, we are getting thoroughly into the understanding of how much rain falls over time when we analyze rainfall data. By using variety of methods to calculate rainfall in specific areas is to prevent natural disasters like flood from happening again. Floods are caused by the construction of unsystematic rainwater flows, and the current flows are unable to handle rainwater if it falls unexpectedly. From this study, there are various hydrologic methods for predicting peak flows from a catchment region. The unit hydrograph can sometimes be a very good predictor of the peak flows. The restrictions are that to use this strategy properly, need amount of data at least 25 years worth in describing how water flows of a particular location each time it rains.